Bueno, hoy voy a leer este artículo que se llama Large Scale Data Driven Financial Risk Management and Analysis Using Machine Learning Strategies. Voy a leer el artículo y al final, pues yo ya lo leí, pero igualmente lo voy a volver a leer en inglés. Elegí hacer la opción 2 y al final voy a mostrar aquí el resumen del artículo. Hice un mapa pues conceptual, como con las cosas más importantes de las secciones que trabaja el artículo. Entonces, empecemos. Bueno, Introduction. The necessity of preventing and managing financial risk has become more crucial in recent years due to several factors, including rising macroeconomic pressure, more regulatory requirements, increased market competitiveness, and increased criminal activity. Commercial banks are risk takers and risk managers in their capacity as financial intermediaries. Commercial banks business environments are getting more complex and riskier as the financial system becomes more complex and global financial integration picks up speed. Commercial banks' ability to gain competitive advantage in this new environment depends on their ability to prevent and control risk intelligently. Extensive data, risk prevention, and control capabilities based on artificial intelligence, biometrics, and big data have become hot topics for financial experts and researchers. Internet of Technology slots can help banks and other financial institutions get real-time data on their own and their client assist improving their algorithm effectiveness for evaluating financial risk. Several businesses had a significant boost in growth due to big data, which was made possible by advances in the field on information technology. Big data refers to data collection that a computer that can quickly obtain, manage, store, and analyze. Big data has improved the efficiency of data processing, exchange, and storage. All of the organization's business, financial, and related data can be seen at the same time. It provides essential data for the early detection of internet credit troubles. Applying big data analytic tools to credit risk management enhances the precision and objectivity of risk estimation and early warning. The multiple discriminant and LR discriminant analysis methods efficiently analyze credit risks. The disadvantages are that it relies too heavily on past data, requires a significant amount of actual data as the premise and has limited dynamic early warning capabilities. The structure of financial management assessment in sketching in addition to using risk commentary models and writing comments on the board. This is accurate. Risk assessment in land relations is usually left to evaluators' skill and whims. The concrete, quickly understood numerical estimations that often apply to hedgement land appraisal risk is a crucial component of the business. It can be challenging to distinguish between poor appraisal and oversight because of the dangerous pricing attitude, which can take many different shapes. There are two motivations for conducting bank difficult research. Regulators can better regulate banks if they understand the variables leading to failure. A bank's bail-in, which its shareholders and bondholders fund, and its bailout can be lower. In this case, regulators can prevent a bank from failing if they uncover concerns early enough. A second factor to consider is that the failure of one bank can often lead to the downfall of their institutions in the financial system. Understanding the causes of a single bank failure can help understand the causes of systemic financial difficulties, whether microeconomic characteristics or macroeconomic imbalances cause them. The root causes, if issues can be eliminated or isolated, preventing contagion effects when problems are discovered. Both psycho and financial venture must consider risk. The rate of return and the level of risk are taken into account by both individual and institutional investors when making accurate and individual investing decisions. Financial risk tolerance plays a substantial role in selecting financial assets and allocating funds in the financial markets. As a result, this element is essential for investor portfolio optimization and personal financial planning. For financial service providers to offer the right services on their clients, it is crucial to ascertain a person's financial risk tolerance. The utmost uncertainty that can be endured when making a financial decision is referred to as financial risk tolerance. Most financial organizations today have developed objective validity ranking systems based on empirical data and methods. Modern systems for evaluating and measuring applicants' credit rely on mechanized methods. Certain applicants' unique essential credit traits are given significant benefits. The client is deemed creditworthy if the sum of these benefits exceeds expectation. Otherwise, the client is presumptively uncreditworthy. The model determines the borrower's credit score based on their past credit data, and the creditor decides on whether or not to grant credit and the size of the credit line. Techniques such as LR, probit regression, non-parametric smoothing, Markov chain model, and recursive segmentation have all replaced the widely used discriminant analysis and linear regression methods. Analytics of large data is typically linked to cloud computing. Real-time analysis of large datasets requires deploying a framework to distribute work to many computers. Understanding ML algorithms in the context of big data is crucial to advance the development of the nation, business, and society. The processing of today's massive amounts of data requires ML overcomes limitations imposed by the human factor. Efficiently process data using deep learning, DLNN, and decision trees, and optimize data process operations. Based on current values, regression makes predictions. Regression uses well-known statistical techniques like linear regression in its most basic form, but in reality there are a lot of problems that can solve with simple linear projections of prior values. For example, complex interactions between different predictor parameters can make it challenging to anticipate product sales volumes, stock prices, and failure rates. Using the same model types of classification and regression is frequently possible. To effectively manage credit risks, financial institutions rely on transparent information mechanisms. Big data can impact how organizations and consumers use the market-based credit system by fusing the advantages of cloud computing and information technology. The main objective of the research is to use ML techniques to predict and analyze the credit risks of financial management. Although this is a small idea, the forecast is more accurate than the current methodology used with a considerable amount of data. One can predict risk and prevent significant losses for the company. The use of this strategy is appropriate for both small and large business. The following are this paper's major contributions. This main research objective is to provide an important aspect of project method for classifying the financial risk. The method for classifying financial risk from input parameters using a large scale test for developing the speed of classification process. XGBoost, KNN are the machine learning are proposed for financial risk management with IO deployment. Curve overall accuracy decision through positive rate and through negative rate are used to determine the performance score. About literature review. Systemic risk study is very recent and closely follows the develops of the financial crisis. An exhaustive analysis is given below. Specific system risk measurements are covered in further detail. In 2021, Carl et al. propose environment learning in economics and finance. By a lot of practice, incentive learning algorithms explain how an agent can learn the best course of action to take in risks, explain how taking a progressive decision-making process. We propose application in economics, game theory, operation research, and finance using the most recent restoration learning approach. The long-term aim to deep learning is to identify an ideal policy or a mapping from the world states to a set of action in order to enhance, emulate, reward. In 2019, Hiko proposed a machine learning method for systemic risk analysis in financial sectors. An important topic in the role of financial system is financial systemic risk. Researchers have increasingly used machine learning techniques in the quest to identify and address systemic risk using the huge volumes of data collected in financial market and systems. These paper measures goal are to explain recent work on financial systemic risk using machine learning techniques and to suggest future research possibilities. In 2021, Junhan introduced a financialization risk assessment for risk control based on machine learning. The goal is to fully utilize a machine learning to enhance the capacity of trade finance efforts to improve the danger of excessive securitization. Data from particular examples are used to examine the precision. The data is gathered and processed using genetic algorithm (GA), neural network, and cyclical component analysis (PCA) techniques, and a hazard analysis model of excessive securitization of financial companies in the developed. In 2021, May Clintworth proposed a financial risk evaluation in shipping, a comprehensive machine learning approach. All stakeholders, including regulators and banks, who depend on reasonable assessment of default risk for both credit institutions and bank loan portfolios, place a high value on corporate financial distress prediction models. The cutler and unclear nature of financial statement data from transport companies has not received enough consideration. In 2021, Bonnie Hyung introduced an evaluation of risk control using machine learning. An essential safeguard for an enterprise healthy development is scientific significant risk. The discipline of parameter estimation and vulnerability analysis has benefited greatly from machine learning technologies, continued progress, and maturity. The enterprise risk scales, which completely represent the numerous traits represented by a company through a variety of elements, are first created in the particular implementation. In 2021, Christian created uncertainty absorption and amplification in machine learning driven finance. Financial products are affected by confusion about market changes and their effects. Machine learning is being used more frequently as a method to take this unknown and turn it into controllable threat. It makes sense, logical, and economic to want to use methods to decrease uncertainty. In 2021, John Tanichi developed a risk management strategy using data envelopment analysis and machine learning. The research proposes a risk management approach that combines data with machine learning. An ML method used in the risk control and treatment procedure to forecast the level of current risk based on simulated data that matches the hazard analysis assumption. In 2020, Lace Jim created a platform based on XGBoost for detecting financial fraud. This study presented our solution for e-commerce operators to detect fraud. This approach mixes manual and automatic classification, which is different from many other efforts. Researchers and engineers may be motivated to develop and implement online transaction systems as a result of this work. In 2020, Shang proposed and applying the XGBoost model to identify consumer transaction fraud. The identification of client data fraud is a critical topic for both the common person and lenders, and it is a hotly debated subject in both science and e-commerce. In this paper, we propose a content and graphical transaction identify verification model based on XGBoost. In 2020, Elorbola designed a method of credit resource management decision making by using machine learning and efficiency. The banks are core The bank's core business credit operation will also contribute significantly to their revenue. Financial distress or risk reaching as a result of a rise financial workloads. The purpose of the study is to support and create innovative technology and organizational models for bank lending that lower credit problems and improve lending performance. In 2019, CowEd designed a systemic risk analysis method using machine learning in financial sector. The role of financial systemic risk to business and financial systems cannot be overstated. Several researchers have been using machine learning techniques more regularly in an effort to identify and resolve hazards using the rising amounts of data collected in financial markets and systems. From the above literature review, the fundamental issue in finance is the pace of innovation by information technology. It covers cryptocurrency development, online transactions, crowdfunding, trading on various platforms, and mobile banking service. Thousands of gigabytes of data are generated by transactions made on the sites. The most crucial factor to consider in this situation is how such massive amounts of data are handled, because they contain sensitive personal and financial data that, if improperly handled, could fall into the wrong hands and have disastrous effects on numerous businesses and industries. The adequacy standard of models to produce accurate risk projections, because they only contain identified and demographic information such as ID, name, age, marriage status, and education level. The situation, as mentioned earlier, significantly limits financial organizations' ability to seek new clients, consolidating heterogeneous, disconnected data from numerous sources and challenging given the models and statistical approaches currently used in financial risk management. So, proposed model. Demand for financing fluctuated from loan provider to finance provider in a cycle. Financing must involve both the supply and demand for the asset to secure the progress of the asset. One type of changeover exercise is financing, which includes cash loans on quick exchanges. From the perspective of assisted managers, venture financing is a financial movement that completes the development of operational property, exercise and employs various budget strategies such as the trading of defenses and the total allocation of resources. Based on their development needs, distinct enhanced strategy will be applied to various types of ventures, promoting the practical and visually simulating activities. They hold the first step in implementing the funding model. Banks are reluctant to lend more money, and early efforts of a firm cannot afford considerable human cost. The building up of specialized capital is the primary driver of venture finance. The architecture of the proposed model is sketched in. Before training and analyzing three models, CAN-MN, LR, and XGBoost, for their capacity to predict loan defaults and their likelihood, the research explore and pre-process the large-scale data. The model's capacity to forecast class levels is evaluated using precision. Recall, if one on Rokow. The reliability plot and the Breer score are assessed using the proposed model. Fig 3. Large scale data. Massive data and complicated data kinds represent big data. A popular framework for processing large batches of data is Hadoop. Its ecosystem includes functional components like Hadoop, distributed file systems, MapReduce, and HBase. Large-scale data processing tasks are broken down and sent to other computing nodes to be finished. Among them, MapReduce implements task decomposition and scheduling and coordinates computing tasks across multiple machines in parallel operation. With increasing relevance and utility in the IoT era, big data is a new phenomenon that results from collecting massive amounts of complex and diverse data generated at any time and from any location. Despite being of the most relevance, big data needs a clear and accept definition. The measure of variability, volume, velocity, veracity, illustration, and value are often used to describe it. The data analysis is made using recent technological advancements that enable the high velocity capture of variable and complicated semi-structured, unstructured, and structured data, make it easier to administer, distribute, and store that data. 3.2. Based on current values, regression makes predictions. Regression uses well-known statistical techniques like linear regression in its most basic form, but in reality there are a lot of problems that can be solved with simple linear projections of prior values. For example, complex interactions between different predictor parameters can make it challenging to anticipate product sales volumes, stock prices, and failure rates. More complicated algorithms might be needed to predict future information. Regression and classification commonly use the same model types. We have here a graphic. One of the most popular statistical one of the most popular statistical techniques for categorizing and linking circumstances is LR. Unlike other statistical methods, the LR model estimates utilizing a different distribution function, making it excellent for credit rating issues. Many methods for creating a binary LR model have been provided to increase the model's precision and adaptability. It seems logical to use LR when the dependent variable contains discrete values. As I previously stated, the creditworthiness domain is real numbers. Wait a minute, sorry, please. Fig 2. Okay, I think is for here. Okay, sorry. Creditworthiness rating discrete 0 and 1 of dependent variable. The popularity or LR is influenced by the structure and kind of behavior of the logistics function as defined like that. The range of this function is a close range between 0 and 1. Its domain is real numbers. Calculate the logistic function value f of u to fit an LR model and statistical analysis method known as LR predict a data value based on prior observations from a data set. In ML, the significance of LR has increased. The technique enables an ML application algorithm to classify incoming input using primary data. An LR model predicts a dependent variable by investigating the relationship within one or more pre-existing independent variables. The result of LR can be interpreted probabilistically and can be regularized to avoid overfitting. Sorry, one moment please. 3.3. A fundamental classification supports the categorization of multiple value data. It analyzes the closest neighbor in each category by using samples from training set to determine the distance of a new samples to each data point. Because of different samples must be compared to complete training data, the procedure of this technique may be computationally expensive if the training set is extensive in size and scope. Furthermore, inaccurate classification will result if the training data contains inaccuracies. KNN is extensively used because it is easy to use, train, and get precise results. This method is employed in various search apps, such as those that suggest related products. KNN is extensively used since it is simple to understand and takes little time to calculate. The parameter k is in this process needs to be carefully selected. Two parameters that must be available for different k values are the training and validation error rates. The KNN method application to text classification has an extensive range. For instance, a system for categorizing public complaints was developed to achieve good governance and democracy and involve citizens in municipal growth. Figure 2 shows the KNA decision rule for two classes of sample with K equal 1 and K equal 2, Fig 1. So Fig 2, this is Fig 2, okay, this is the graphic, and Fig 1 is high, up, okay, this is Fig 1. Okay, so we are here. A. Illustrate the classification of an unknown sample using a single known sample, whereas B. Illustrates the classification of an unknown sample using several known samples. The parameter K is set to 4 in the final scenario, meaning that the 4 closest to unknown sample are used to classify it. Only one is from the other class, while 3 are from the same one. The KNA algorithm is shown defined in algorithm 1 and graphically depicted in figure 2. And 3.4 XGBoost. XGBoost is a sharp gradient boosting implementation that may be applied to regression predictive modeling. Test an XGBoost regression model using the best practice method of repeated k-fold cross-validation, where the task at hand involves classification or regression. The ML algorithm is most frequently used. The fact that it outperforms all other ML algorithms is well known. The XGBoost package includes an implementation of the gradient boosting decision tree technique. This method goes by the titles gradient boosting, stochastic gradient boosting, multiple additive regression trees, and gradient boosting machine. It is an open source implementation of gradient boosted trees that is well liked and effective. Gradient boosting is a supervised learning technique that combines the prediction of several smaller, weaker models to predict a target variable with some degree of accuracy. Excellent tree boosting methods include XGBoost, also known as extreme gradient boosting, according to time-kick chain regularization to accommodate sparse data, and weight quantile search for tree learning are two features of XGBoost. They also offer insights that help create quite a scalable tree boosting method. Some of the revelations are data comprehension, sharding, and cache access patterns. Because of that method and insights, XGBoost outperforms model or ML algorithm in terms of speed and accuracy. For engineers or data scientists using XGBoost systems in distributed system or GPU, machine learning is particularly practical. The loss function is normalized using gradient descent algorithm to attain better prediction score. Training data helps this model learn over time, and the cost function within gradient descent specifically acts as a barometer gauging its accuracy with each iteration of parameter updates. Okay, results and analysis. In financial risk prediction, accuracy and error rates are critical indicators of categorization system, measures of the receiving operating characteristic curve area under the curve. Overall accuracy, precision, true position rate, and true negative rate are used to determine the performance score. Numerous changes have been made for the KNA approach. It was shown that text categorization performance is enhanced by a flexible KNA approach that combines a weighting technique and k-variable algorithm, combining some other ML types and KNA classification, which increases performance, and by classification accuracy is another refined KNA method by merging model and evidence theory. A novel KNA classification algorithm helps to get beyond some of the drawbacks of traditional KNA approaches, namely time-consuming learning. Accuracy in the proportion of cases that are correctly categorized It is one of the most well-liked performance metrics for categorization. These terms are used to describe true positive, negative positive, false positive, and truthful positivity. FP is the percentage of situation incorrectly labeled as fault prone but is nonetheless included in the category. The number of incidents mistakenly classified as non-fault not prone is known as FN. The percentage of possibility of abnormal events that are actually positive is known as precision. Operating characteristic on acronym for the trade-off between transmission and reception rates used here. The independent variable, the ratio of observation of the first type of dependent variable outcome that fall into appropriate category of independent variable to observation of the second type of dependent variable outcome that fall into the appropriate category in the dependent variable is the natural logarithm of the weight of evidence formula. In the analysis, the index should be short from small to large before calculating the appropriate wow. The greater positive index, the higher the reserve index, the higher the Y value, the lower the low index. If the reaction index is more positive and the disaster value is less positive, the index has a become chance of being identified. The closeness of its value to a straight line indicates a need for more capacity to interpret indicators. The index is judged on economical and needs to be deleted if the positive index has a negative correlation with the catastrophe. Results analysis. The proposed architecture is simulated using layered scala online datasets for past few years. The results are analyzed for the optimized data-driven risk. The simulation results conclude that the proposed model works better in parametric search over the existing techniques. The average stock return from some of the recent months is drawing figure 4. These datasets gathered from FNCE 5P3 13. This split into training and testing for training 30% and testing 70%. The proposed model outcomes are compared with the other methods and depicted in the simulation results prove that more than 74% of the purchase of total assets in a single iteration yields good performance. The investment comparison with some other approaches is plotted in figure 5. The wet versus years comparison and optimal consumption are plotted in figure 6 and 7. Respectively, the inferences conclude that when there is a gradual increase in wealth, its trajectory has up and downs, since some tangible purchase is sometimes require the inverse well proportion measuring of the proposed model ranges from 0.02 to 0.09. Applying the value at risk strategy, the optimal consumption stability not exceed the 5% of total investment wealth. The performance metric comparison of the proposed model with other techniques such as FABC 35, IFABC 36, and QFABC 37 is shown in the table 2. The following are the essential inferences obtained from the simulation. The distribution of investments is better than other models. The proposed strategy is applied to a sparse problem. The proposed method controls the global measures. The complexity and risk are reduced when applying a large scale investments. Finally, conclusions and future work. Competition in the bank industry means that service quality during credit risk assessment is essential. The bank should review the credit request as soon as feasible to gain a competitive advantage. Because of the importance of financial risk analysis, financial institutions produce the majority of approaches and models to determine whether or not to give credit. KNN is a popular classifier since it is simple to use and effective. The most challenging aspect of the KNN method is determining the appropriate value of K, which knows the number of neighbors. KNN, LR, and XG boosts vary based on all measures. Thus, the research analyzed which attributes were most important to the main prediction using information gained. The control parameter determines the accuracy and cost trade-off to predict the observation strength. The simulation results prove that the proposed representative works better. We have the graphics here than the state-of-the-art methods. The investor's well-proportioned measure of the proposed model range from 0.02 to 0.09. Applying the value at risk strategy, the optimal consumption stability not exceeds 5% of the total investment wealth. The simulation result of the proposed model obtained better results of large scale driven financial risk over the state-of-the-art methods. The following the following are the future enhancements. Okay, this is the final of the document. So now I'm going to explain in Spanish the resume. O sea que ahora cambiamos el chip a español y voy a explicar en español pues un resumen que ya había hecho antes de esto, pues porque lo leí, lo traduje, porque la verdad pues estoy practicando inglés, todavía hay cosas como que me falta mejorar la pronunciación y eso, pero bueno, lo traduje, lo leí en español y aquí saqué como las cosas más importantes. Ahora lo voy a explicar en español. Entonces, el texto se divide como en varias partes. En la introducción nos empieza hablando de la importancia del análisis de riesgo financiero en el sector bancario. Eso es muy importante para que los bancos mantengan su salud financiera. ¿Por qué? Porque les ayuda a decidir si deben aprobar créditos y cómo manejar sus inversiones de manera inteligente. También nos habla del uso del KNN como un clasificador popular. ¿Qué es el KNN? Es el Key Nearest Neighbors, que es un método fácil de usar que clasifica los datos. Es efectivo y no es complicado de implementar. Y también nos habla de unas métricas de evaluación que son 3: precisión, TPR y AUC. Pues ya lo vamos a definir más adelante, pero precisión es qué tan correcto es el modelo. TPR es la tasa de verdaderos positivos y AUC es área bajo la curva, que se usa pues para medir qué tan bien funcionan los métodos de predicción. Luego el texto pues nos habla del resultado y análisis, ¿cierto? ¿Y qué tenemos? Primero, mejoras en el KNN. Se han realizado pues mejoras en el KNN, que se han utilizado enfoques que otorgan más importancia a ciertos vecinos y combinándolo con otras técnicas de aprendizaje automático para aumentar la precisión de la clasificación. Luego tenemos unas definiciones clave, que la precisión nos da la fórmula pues en la página 5, lo puse aquí, a ver, la precisión, esta es la fórmula para calcular la precisión, que es la proporción de clasificaciones correctas, y la tasa de verdaderos positivos, como lo habíamos mencionado, que es la proporción de verdaderos positivos en relación con todos los casos que realmente son positivos. Y otro resultado pues es el peso de evidencia WOE. El WOE se utiliza para ver cómo varían las tasas de buenos y malos préstamos en diferentes categorías. Se calcula también con una fórmula que está ahí en el libro. Y ahora sí, finalmente pues el análisis, antes de las conclusiones, el análisis de resultados. En el análisis de resultados tenemos primero simulaciones con grandes conjuntos de datos. Se llevaron pues a cabo varias simulaciones con conjuntos de datos grandes para comprobar si el modelo propuesto realmente funciona en situaciones reales. Comparación del rendimiento. Los resultados que se mostraron demuestran que el modelo propuesto supera a otros métodos en la predicción de riesgos financieros, mostrando mayor precisión y efectividad. Y el gráfico de resultados tenemos pues primero retorno de inversión promedio, se presentan pues gráficos que muestran cómo varía el retorno de la inversión en diferentes periodos. Tenemos también la distribución de inversiones, que se analiza cómo se reparten las inversiones y su rendimiento, y finalmente la estabilidad del consumo, donde se discute que el consumo no debe exceder el 5% de la riqueza total invertida, asegurando un enfoque sostenible. Y ya finalmente pasemos a las conclusiones y trabajo futuro. En las conclusiones tenemos primero pues la importancia de la evaluación del riesgo crediticio. Se planea pues agregar nuevas restricciones. O sea, la evaluación rápida y precisa de los riesgos de crédito es esencial para que los bancos se mantengan competitivos y tomen decisiones informadas. Tenemos la efectividad del KNN y nuevas técnicas. Se concluye pues que el KNN junto con otras técnicas como regresión logística y XG Boost ofrecen los mejores resultados. Eso significa o indica pues que es importante seguir buscando métodos de clasificación eficaces. Y ya las ideas para futuras investigaciones son primero pues ahora sí nuevas restricciones de análisis de datos, donde se planea pues agregar esto para mejorar la precisión, exploración de factores adicionales, donde se va a buscar analizar otros factores que puedan influir en la predicción del riesgo financiero, y el desarrollo de estrategias de computación blanda, donde se va a investigar pues nuevas estrategias de computación para manejar análisis más complejos y reducir riesgos. Eso fue todo. That's all for today. Espero que les haya gustado. Pues nada, esta fue la exposición de esta semana 7 o 6. Uy, ya vamos muy adelante. Bueno.